All right, so we want to talk about acid-base balance. It's the second half of chapter 25. Acid-base balance is important because of all of the proteins in our body. So all of the proteins have to be in the right solution and the right pH in order for them to have the right three-dimensional structure and in order for them to actually work. So enzymes won't work if the pH isn't right. All right, now the pH range that we normally function in for extracellular fluids and blood is normally 7.35 to 7.45. So there's a very, very narrow window where everything is okay. Our metabolism tends to produce acidic compounds. Okay, so things like lactic acid, phosphoric acid, fatty acid, ketones, carbonic acid. So we tend to make acidic compounds and our body tends to become more acidic. So we're always struggling to bring it back to this range. Okay, now what's an acid and what's a base? Okay, so acids are things that ionize and give up a hydrogen ion. Okay, so a strong acid is something like hydrochloric acid, which is HCl. Okay, so it's really easy for it to give up a hydrogen ion. Okay, weak acids are things like vinegar, like acetic acid, carbonic acid. Okay, they give up hydrogen ions, but not as readily. Okay, now these things are everything always has a hydrogen in front of it. Okay, so it's always got a hydrogen. That's how you're going to know it's an acid. Okay, now bases do the opposite of acids. Okay, so they bind a hydrogen ion. So a strong base is something like sodium hydroxide. Okay, so it's usually got an OH on the end. So that's an example. So sodium hydroxide. Okay, now weak bases ionize slightly, okay, but not as much as like sodium hydroxide. So an example of that would be HCO3 negative. Okay, so it'll give up an OH. Okay, or it'll accept a hydrogen ion. Okay, so it'll pick it up and then it becomes this. Okay, now we want to, we want to talk about pH, okay, and the pH scale. So it's important to review this. So remember the pH scale goes from 1 to 14, okay, 7 is neutral, okay, 1 is acidic, 7 to 14 is considered basic or alkaline. Okay, so the more acidic you are, the more hydrogen ions you have. Okay, so there's an inverse relationship. So when pH goes down, the number goes down, hydrogen ions go up. Okay, so pH is the negative log of the hydrogen ion concentration. All right, that's the chemistry of it. Okay, so hydrogen ions go up. Okay, there's less hydrogen ions as the pH goes up. Okay, so if your pH is going up, your hydrogen ions are going down. Okay, so there's an inverse relationship between the two of these, and you need to make sure you remember that. That's really important. Okay, now a buffer is something that is going to resist a change in pH. So you could think about bufferin is a type of aspirin or enteric-coated aspirins. So aspirin is acidic. So bufferin, enteric-coated aspirins, they're covered in a buffer so that the pH in your stomach doesn't become more acidic than it already is. So the idea behind the buffer is that it's going to convert a strong acid or a strong base to a weaker one. Okay, so it kind of neutralizes it. Okay, now there's two kinds of buffers in our body that we have to talk about, so two broad categories. One of them is a physiological buffer, and the other is chemical buffer. Our physiological buffers are the urinary or the respiratory system. And the reason that they work so well is they are actually able to excrete out carbon dioxide, which you'll see the relationship between carbon dioxide and hydrogen ions here soon, or excrete out hydrogen ions. Okay, so they can actually remove these ions from your body. Okay, they are slower to work. Okay, so minutes, hours. Okay, but they're very powerful, so very strong. Okay, now our chemical buffer systems work really, really fast, but they're not as powerful. So what they do is they just convert a hydrogen ion into another substance. So they bind it or they remove it from the solution and they add it to something else. Okay, so they're gonna move it around. They're not actually getting rid of it, but they're moving it around. Okay, so a physiological buffer would be like if you clean out your piles of papers and you actually put them in the recycle bin or throw them away, where a chemical buffer system is you still have all the piles, but you're shuffling them around. You're just moving them from one table to the floor and back up to another table. Okay, so chemical buffer systems are not as powerful, but it's moving things around so that it helps you. Okay, so examples of chemical buffers are bicarbonate, phosphate, and proteins, and we're going to talk about each of those in detail. Okay, so the bicarbonate system is very important in your blood. Okay, so that's where we're going to find it. So extracellular fluid. Okay, now if we look at this, it's CO2 plus water. Okay, so carbon dioxide plus water leads to this H2CO3, and that's going to break down and give us HCO3 negative plus hydrogen ions. Okay, so carbon dioxide and water you're okay with. This compound here, this is called carbonic acid. Carbonic acid is not stable, okay? So when it's in water, it's going to break apart. It's going to dissociate. So it automatically gives rise to this, which is bicarbonate. Okay, and a hydrogen ion. So if a hydrogen ion is released, right, if you have an increase in hydrogen ions, we're going to have a decrease in pH. Okay, and then the opposite, if we have a decrease in hydrogen ions, we're going to have an increase in pH. Okay, now, this reaction, this whole thing is reversible. Okay, so it can go either way depending on what's in excess. So if hydrogen ions are in excess, we'll go this way. Okay, if carbon dioxide is in excess, we're going to go this way. Okay, so this is what this is trying to show. So if we are going this way, okay, we're going to be releasing hydrogen ions. Okay, if we need to go this way, okay, we're binding hydrogen ions. Okay, now, this partners with the urinary system and the respiratory system, because if we can free up the hydrogen ions, we could pee them out. Okay, if we can free up carbon dioxide ions, we can exhale them. Okay, now, phosphate buffer system. This is in the cells. Okay, so in the ICF. Okay, so it's going to be important in the ICF and in the tubes in your kidneys, so the collecting duct. Okay, this, what it should look like is H2PO4 negative. Okay, and we can go to HPO4 2 negative plus hydrogen ions. So essentially it works the same way, right? So it can go back and forth. It just has one less step. Okay, so if we have excess hydrogen ions, they can get bound to here. Okay, and we're going to go this way. Okay, and that'll take our pH back up. If we have excess, if we need to free up hydrogen ions, if we have excess base, then we're going to go the other way. Okay. Right, so they go either way. Okay, so in cells, that's what I want you to know. I want you to be able to recognize this. That's it. Okay, now proteins. Okay, so proteins are the biggest buffering system that we have. Okay, biggest chemical buffering system. So I have more concentrated than bicarbonate or phosphate systems, especially in the cells. Okay, so it occurs in the blood and the cells, and I want you to go back and think about what you know about amino acids. Okay, so this is the we call it the carboxyl group, or it's the carboxylic acid. Okay, so if it needs to, okay, this can be ionized and can be released. Okay, the amino group, which is over here, right, the amino group could pick up a hydrogen. Okay, so essentially these amino acids are working as a buffer. Okay, so they could be picking up hydrogen ions if they need to, or they could be releasing hydrogen ions as necessary to buffer. Okay, so this is going to release hydrogens when the pH increases. Okay, and then this will collect hydrogens when it goes the opposite. Okay, this is the big one. This is the most important one. The most important chemical buffering system. Okay, now respiratory system. So the respiratory system, okay, and we have to talk about that. It works with the bicarbonate system. Okay, so there's a relationship between carbon dioxide and pH. Okay, so carbon dioxide plus water. Okay, if we go this way, that's supposed to be an arrow, and that's supposed to be an arrow. Okay, so what happens is if we go this way, okay, we can add hydrogen ions and we can lower the pH. Okay, so carbon dioxide goes into the bloodstream. It binds with water. Okay, it actually releases hydrogen ions. Okay, so basically, here's what happens in your blood. If your carbon dioxide level goes up, okay, your hydrogen ion level goes up, and your pH goes down. So this is acidic. Okay, so if someone has like a COPD, okay, and the carbon dioxide is accumulating in their blood, okay, because of this equation, they're going to accumulate more hydrogen ions, and they're going to become more acidic. Okay, if someone is going the opposite, okay, carbon dioxide goes down, hydrogen ions are going to go down, and the pH is going to go up. Okay, so this is important. So if you're too basic. Okay, so direct relationship between carbon dioxide, hydrogen ions, and pH. Okay, it's really important. They all go together. Okay, so carbon dioxide and pH stimulate pulmonary ventilation, while a decrease in pH is going, oops, wait a minute, this should be increase, and this should be decrease. Okay, so increased CO2 and decreased pH are going to stimulate pulmonary ventilation, and a decrease, right, that should be up. An increase in pH inhibits pulmonary ventilation. We are going to go back, we're going to talk about this in the respiratory chapter, okay? So just hang on tight to that. Okay, now Renal control, what happens, so this is the most powerful one, because what happens is we can actually release the hydrogen ions out into the urine. Okay, so the way that this works, which this is kind of complicated, and I'm not sure how much of this you need to memorize. Okay, so here's the idea. So if we go here, so number one, so the carbon dioxide, okay, is going to move into the tubules from the blood and the filtrate. Okay, so here's the blood. Okay, here's your bicarbonate or carbonic acid. Okay, water combines with it, and we get CO2. Okay, so CO2 can then cross into the cells, and it'll go into the urine. Okay, the CO2 will bind with water that's in the filtrate. Okay, the hydrogen ions can actually be released and will be flushed out. Okay, so we can kind of go this way too. So if we go, the fate of the bicarbonate, okay, goes this way. Okay, so what's going to happen? Okay, so if we go here, then this will cross. I feel like I'm butchering this. I'm going to stop it, and then I'll repeat this for you guys instead of making you just